So welcome to my first instructional video. I'm calling it What is Chemistry? My name is Don Gibbs. I teach Honors Chemistry and AP Chemistry here. And although you might have lots of ideas about what chemistry is, and of course they're all valid, I thought maybe I would give you a brief overview or introduction to the course and to what I think chemistry is. Well, sometimes we describe chemistry as the central science. Central might mean integral, and it certainly is tremendously important. Central might also mean that we're talking about something that is in the middle. And in that sense, I think that kind of fits. In the Pomfret curriculum, the science curriculum, we first stop at physics, and then chemistry, and then travel to biology. And so the central science, chemistry, links physics and biology. How does it do that? Well, in physics, you no doubt learned about energy. You might also have learned about how it's transformed, how it can be harnessed to do useful work. You probably learned a little bit about the atomic model and no doubt about the different phases of matter, solid, liquid, and gas. And you probably learned a little bit about forces of attraction and how to describe forces that might provide the glue that hold things together. And in chemistry, we're very interested in how atoms connect and the nature of those connections and the properties that that new material, that conglomerate of different atoms makes. We call those molecules. And in biology, biology is increasingly molecular. The organization of molecules, how atoms fit together to form molecules, and how those molecules might be built to, in concert, form living systems. That's what biology is all about. So for us, chemistry is right in the middle. It is definitely the central science. Well, chemistry is important because it's all around us. And it's in the air that we breathe, the composition of those gases, how gases behave, how they interact with you and with each other. It's around us all the time because of the materials that we use. And it's around us, of course, because we harness the materials that make up the earth. Sometimes we combine them in new and useful ways. So you might remember from our summer assignment the idea of taking atoms, different types of elements, and colliding them and smashing them together. Well, that's one type of chemistry. That's not everyday chemistry, however. The idea of synthesizing new types of elements and trying to overcome that island of instability, or sea of instability, and find the island of stability, that's not really the work of most chemists. Instead, many chemists are tracing molecules and compounds as they move through the environment, chronicling the reactions that allow them to change from one material into another. Maybe even talking about the energy that is derived from tapping those connections, breaking old bonds and forming new ones, the types of reactions that might create energy. And of course, you've probably seen the periodic table. And the periodic table, of course, is an organization of the known elements. And you might be surprised to learn that they have families. That means atoms are somewhat related to each other or are similar to one another based on the type of chemistry and reactivity that we can experience. And so chemistry is really all of that. It's what makes up atoms and how those pieces behave in concert to give the elements their individual identity. It's chronicling the changes that happen as atoms combine in chemical reactions, the energy that is involved, the steps that are involved in making materials go from reactants to products. And it's a lot about the individual elements and their properties, but the collective properties of molecules and how we can learn more about how they're organized and what useful work we might be able to get out of them. So chemistry really is all about the atom then. And so a few questions that might drive our conversation are, what are the parts of the atom and how are they arranged? No doubt you've learned something about this from previous classes. What attributes or qualities do those parts have, and what makes one element distinct from another? Why can we say that a carbon atom, for instance, is distinct from a magnesium atom, but still different from a calcium atom? What similarities unite atoms, and then what differences do they have? Other questions that we might have too would be, so here's a picture of a calcium atom and a bit of a chart describing its pieces. Is this the only way to be a calcium atom? Are there some components in this tally that are fixed and others are variable? What happens to the properties if we alter one of these? Does that happen naturally? And of course, another really good question would be, if I wanted to combine these, how would they combine, or would they? What parts would mix? What would the resulting molecule, a combination of atoms, look like? Is it just a smacking into each other of these two shapes, or is it something different? And how can we model that in a way that seems effective? So the atom is what chemistry is all about. Our job is to chart the atom and understand how atoms combine and rearrange, the new properties that they take on, the energy change that's associated with those reactions, and trying to figure out the forces that help reactions to go. All of that and so much more, from the synthesis of new compounds to understanding the speed by which reactions take place. That's what chemistry is all about. So in our next video, I'll tell you something about your first